1.6, classifying polygons. Classifying polygons. There's the first batch of notes, and we'll talk about them in a second. So if you want to start, if you're a reporter, then record. Your first test will probably be at the end of this week. That was just a quiz. Your first test will probably be at the end of this week. Yes, ma'am. Test is worth 100 points. Quiz is worth anywhere between 25 and 40. Much shorter, and it won't be out of your books. Yes. Quizzes, tests, it's all about finding out what you know. Quizzes, I'm more interested in finding out what you could know if you put a little bit more effort in. That's why I give you open book and stuff. Okay. Oh, I think I forgot to actually pull down the root word above this. Polygon. A polygon is a figure. Basically, this is a polygon. That's the big vocab word, and I guess I actually cut it off. A polygon is made up of sides and corners and angles. The big thing about a polygon is that it's enclosed and all of its sides are straight. So all straight sides, and there can't be an open portion. These two pieces couldn't bend up and leave a gap. It has to be enclosed, and all the pieces have to be straight. And when that's the case, and you have a polygon, you have your sides, which are obviously like the sides of your polygon, and your vertices, made up of individual vertexes, which are basically just your corners. So, sides and vertices. Now, you name a polygon by all of its vertices. So, this could be A, B, C, D, E, it could be C, D, E, A, B, etc. One thing you want to get in the habit of, though, you're going to be having some homework problems where it's like, here's the directions for drawing a vertex. Now, draw it. You want to write all your letters in order. Okay, now, this one, if you had started up here, that's fine, but you want to go C, D, E, A, B, or D, E, A, B, C, or D, A, B, C, D, etc. If you mix those up, it's going to mess up how you draw it, all right? Because if you write them in this order, then you know, oh, I start at C, then I go to D, then I go to E, then I go to A, then I go to B. Whereas if you were like, oh, this is polygon B, B, E, C, A, you're going to draw it horribly differently, and your answers are going to vary. So just make sure your sides are in order, your vertices are in order. Okay, let's see. Questions on that slide, I guess, before we go on? Just remember, everything is in your book in 1.6. If I move on, you're not quite done. The notes are right there. Oh, it's frozen. A polygon is convex if no line that contains the side of the polygon contains a point on the inside. This is why we talked about interior earlier. Convex is something where none of the sides kind of cave in on it. Concave, they do. That's why I use the expression cave in. For instance, if you were to keep drawing any of these sides, none of them go inside the polygon, so it is convex. If you were to continue drawing one of these sides, or this one, the line goes inside the polygon, so that would be called a concave polygon. Concave, convex. Questions about what makes those different? I'm about to ask you your own. Okay, convex or concave, or is it even a polygon? What do you think about A? Why not? Yeah, one thing, and I may have not mentioned this earlier because I actually cut that part off. Another thing that a polygon can't do is you can't have a side of a polygon that goes literally right through your polygon. Okay, now this could be two polygons, but it's not one polygon, which is what it asks. Tell whether it's a polygon? No, it's not. What about B? Would that be a polygon? Yes. Would it be concave or convex? Convex. Very good. None of the pieces cave in on each other. What about C? Perfect. You cannot have a curved piece in a polygon. So no. What about D? Yes. What do you think? Concave or convex? Concave. Because if you keep drawing pretty much any of these sides, you're going to go inside the polygon. Questions? I should probably write down these answers as we do them. All right. All right. The most popular, well, I won't say most popular. The most commonly used polygons are these. Now, you don't have to memorize these, okay? I'm not going to require you to be like, hey, here's a seven-sider. What's it called? That's not really the point. But you should know in your homework or assignments, they may say, hey, here's a heptagon. So it would be kind of handy to know it. But if you're ever on a test or something, and it just says heptagon, and you raise your hand, I can be like, oh, that's a seven-sided figure. Okay? Those will stick with you over time, but it's not really the point of the class. Anything with more than 12 sides is called an ingon. So like let's say we're dealing with a 17-sided figure, that would be a 17gon. Okay? That's just because they run out of prefixes after 12. So that's just the point of that. Questions from this slide? All right, more vocab. Equilateral, equiangular, and regular. I think the easiest one of those three vocab words to know what it means is equiangular. Because guess what that means? The angles are all equal, that's right. It means in that polygon, every angle is equal. And if equiangular means angles, what do you think equilateral means? All the sides are congruent, that's right. And if both are the case, like in our picture here, if it's both equilateral and equiangular, then we call it regular. Now, regular is like the sly dog piece of vocabulary of the day. That's the word they're going to slide into your directions. And because you've dealt with the word regular your whole life, you're not going to think much about it. But regular is going to provide you a huge hint today. Anytime you see the word regular, you should know, oh, that means all the sides and all the angles are congruent. So, we're going back to our hand gestures from last week. If all the sides or angles are equal, guess what you're going to do with them when you have to solve for pieces? Set them equal. Very good. Setting lots of things equal today, whether they be angles or sides. Questions on that vocabulary? All right. Here we go. Classify the polygons as, well, first by the number of sides, then tell whether they're equilateral, equiangular, regular, or none. A, how many sides did I got? 6. Anybody remember what that's called? Very good. Hexagon. Now, remember, you're looking for dashes and loops. Let's look at the sides first. Are all the sides equal here? Yes, they are. They all have exactly one dash. Therefore, it is equal. It is equilateral. What about the angles? Are they equal? That's right. And if it's both, then it is regular. Regular. What about B? Is it equilateral, equiangular, or neither? Or both? What can make it regular? It is neither. This angle and this angle have different number of loops, so they're not the same. These have different numbers of dashes, so they're not the same. So this would be a neither. And what, anybody remember what this would be called? Four-sided figure? Quadrilateral. Very good. A square implies something we'll be going over in a few sections. But this, a regular four-sided figure would be a quadrilateral. What about C? This one's tricky. What about equilateral? Let's start with that one. Are all the sides equal? Yes, they all have the same number of dashes. Now here's why it's not regular. Here's why it's not equiangular. Because when you're looking at these polygons, you're looking at the interior angles. This angle is 90, this angle is 90. But what about this angle? You have to look at the interior angles. See, this is a very tricky one because you look, you say, oh, 90, 90, 90, 90, 90, 90. But this is an exterior angle. So you have to, well, we haven't really covered this yet, but you would subtract that from 360. But one way or another, this is not 390, so therefore it is not regular, and the whole thing would just be equilateral. Equilateral. Questions? It was neither.
Never be.
Hey, technicalities, people. I do that kind of thing all the time. Questions? Two more. If the polygon is regular, then solve for x. Well, I'm telling you it's regular. I accidentally cut off the directions in English. If the polygon is, and I'm telling you that it is regular, how am I going to solve this? Set them equal, because the sides are equal. So 2x minus 1 equals x plus 3, and you just solve for x. Add the 1 to the other side. And x equals 4. And if you plug that back in, you should get the same thing. Not that you have to, but that would be 7 and 7, so it works. Questions? Try this one on your own. And I'll pick somebody at random to tell me the answer, so don't blurt it out. Malik, what do you get? 5. So you set them equal, I'm guessing? Subtract 2x. You get x plus 1 equals 6. Subtract the 1, and you do get x equals 5. Very good. Questions? You're going to be setting things equal. In fact, you only have 3 or 4 problems today where you even have to do that kind of math. Most of today is vocabulary. But when you do, you'll be setting things equal. Questions on that problem? Now, one thing I didn't pull aside, but I wish I had, someone flip over to your book where the problems are and read number 17 aloud. I forgot to attach one of these. We're just going to work one straight from your homework together. What does number 17 say? Someone read it nice and loud. Yes, ma'am. Whoa, 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 you read so fast. 3x minus 9 and what? Are what with each other? They are two of the sides of an equilateral triangle. Okay. which means I have a triangle here. Those are the sides, and what do I know about an equilateral triangle? You're going to have to use context clues. Equilateral means their sides are equal. So what do I need to do with these two things? Did it ask me what the length of the sides were, or did it ask me for x? Sides. So that means I need to solve for x, then plug it back in. So what do I do with these? Set them equal. That's right. Set them equal. If they are equal, then you set them equal. So let's add 5x to both sides. Again, this is number 17 in your homework. So that'd be 8x minus 9 equals 23. Add the 9 to both sides. Divide both sides by 8, and what do you get for x? (32) divided by 8. That's okay. I figured you just misread it. And I'll circle it with bananas here so you know where the answer is. So x equals 4. Questions? I'll call about the heat in just a second. That's as hard as they get today, where they're not going to give you a picture, but they're going to be instructions. And if you draw out the shape that it tells you, you can normally figure out what the sides are. I believe that was the hardest one of those 3 problems, 15 to 17. So. Questions? All right. Well, all done in like 10 minutes. Way to be productive. Here we go.